Here we go. Secant x equals negative radical 2. Solve for x. Here's our procedure. Try to write all terms as variations of sine, cosine, or tangent. That's not a sine, cosine, or tangent. So let's replace it with its equivalent form in one of those three options, right? What can I replace secant with? Should know this at this point in the unit. Secant is 1 over cosine. So I'm taking this out and putting this in its place. Okay. Now we kind of got a problem here. I don't know if you see it, but that thing we're supposed to isolate, that cosine x that we're supposed to be solving for and getting all by itself, it's down here. I don't just get to like take it out and be like, I'm done. No, it's the same. Whether it's in the bottom or the top, who cares? No, it matters, right? But I do have a method for getting it out of there. And this is something, again, we've talked about numerous times throughout this course. I call it the switcheroo. The switcheroo works, okay, just as a brief aside, okay? The switcheroo works when what you're solving for is in the bottom of a fraction. We can swap it with what's outside on the other side. Take everything that's over here, move it down. Take everything that's down here and move it out. That's the switcheroo. It's a shortcut. It works. I've explained how it works before. Okay? My students should know because I've talked about the switcheroo probably a dozen times or so this year. So what we can do is take this, that thing that we're supposed to be solving for, and take this and switch them out. Now this problem will say 1 over negative radical 2 is equal to cosine x. How about that? We got our cosine x all by itself. We just moved it out of the fraction and put something else in its place. The thing that goes through my mind when I think about this is that scene from, I think it's Raiders of the Lost Ark, Indiana Jones. You guys seen that? You've seen it, Nicholas? You have? Oh, good. Do you know what I'm talking about? It's in the very beginning. There's like this golden idol sitting on this thing. You guys have seen this scene before. I know you have. And he's got like the bag of sand. And he's like, and he does that. Right? Then what happens? Then the people start to chase him and the ball is rolling and he's trying to run away. Like everything just goes crazy. It's kind of the same idea. We did the switcheroo. Now it's like, oh God, now we're in trouble because we actually have to solve this. Okay, sorry I got off topic there. So we have our isolated term. Every time we get our isolated term, we're supposed to say, okay, where do we see this number on the unit circle? And it's like, whoa, 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 pump the brakes there for a second because we shouldn't have this radical down here. So let's get rid of it. Let's multiply by radical 2. We call that rationalizing the denominator. How many times have we done this? Okay, and in doing that, we get a radical 2 on the top. On the bottom, we just end up with a 2, and I'm going to put a negative there like that. And once again, you ready? You ready? You know, maybe you know where I'm going with this. Remember when we were solving this problem? And we got to the point where our cosine was isolated, and we had it equal to something, and we asked ourselves, okay, what are the angles that have this as an x-coordinate? Well, ask yourself that question now. What are the angles on the unit circle that have this as their x-coordinate? So you go to the unit circle, and you find negative radical 2 over 2. I'll give you a hint. If the x-coordinate's negative, you gotta be here. What is it? 3 pi over 4 and 5 pi over 4. plus 2 pi n, don't forget that. There it is, okay? Isolate the trig term, and then find the coordinate that is associated with whatever trigonometric function we're looking for. That's it.